Hello friends, in today's question, a wooden block performs SHM on a frictionless surface with the frequency nu naught. The block carries a charge plus Q on its surface. If now a uniform electric field E is switched on as shown, then the SHM of the block will be, so these are the four options. So it basically means that SHM will be having the same frequency or a changed frequency, and the SHM will be executing at the same mean position or a changed mean position. So these are the, you can say, two broad combination based on which these four options are given. So first of all, let's try to understand what is the key point for our SHM. Key points of SHM. So first of all, one of the important part of SHM is our restoring force. Restoring force in SHM. So from the figure we can see the block is connected to the spring, and so the restoring force will be, you can say, activated with the help of this spring, and it will be proportional to the amount of the displacement this block makes from its mean position. Okay, and if we say x is the displacement from its equilibrium position or mean position, then the restoring force of the spring will be equal to minus kx. Okay, where k is the constant of this spring. Let us suppose this is k, spring constant. So we can say restoring force in SHM, the block is connected to the spring so the restoring force due to spring is proportional to displacement which we say is x from its mean position, from its mean position. Therefore, we can write that restoring force, which is written as F spring in case of spring, will be equal to minus k of x, and the frequency of SHM which is also called as a natural frequency, or we can say in the first case it is without a electric field, without electric field. So in this case it is said that the frequency is represented by nu naught. Usually we can use also f or f naught. So we can say nu naught will be equal to 1 upon 2 pi square root of k upon m, where m is the mass of the block and k is the spring constant. So this is the basic premise of the, in case of SHM, one is the spring force, restoring force, and another one is the frequency of SHM. Now let us consider the effect of the electric field. effect of electric field. Now in the question it's mentioned that uniform electric field is applied, effect of electric field, and it is represented as E. So we can say a uniform electric field is applied. Therefore, and it is also said that the block carries a charge of plus q. Okay. So therefore, you can say block experiences a constant electrostatic force. Because of charge q, plus q rather, because of charge plus q. So therefore we can write that force due to electric field, let us call it force electric, will be equal to q multiplied by the applied electric field, and q is the charge. Okay. And it is said that the force is constant. Okay. So we can say from here that this force is constant and acts in only one direction, and direction is also shown in the figure. It goes from left to right. It's only in one direction. So let us consider what will be the impact of this electric field on the, you can say, SHM. Impact on SHM. First impact will be that as soon as the electric field is applied, the force will be acting on the charge, or we can say indirectly the force will be acting on the block, and all of a sudden there will be a shift in the mean position. Okay, or we can say there will be a shift from the equilibrium position. So first impact will be shift in the mean position. Shift in mean position. And we already said that the electric field is going to exert a force on charge q, or indirectly on the block, which is given as F electric is equal to q multiplied by E. Okay. So from here we can say that since electric field applies a constant force and which is given as F electric is equal to charge multiplied by electric field. Because of this, you can say it causes the mean position of the block to shift by some constant displacement, by some constant displacement. Let us call this as x naught. And this position x naught we can easily find out, because as soon as the spring force becomes equal to the force which is being applied to because of the electric field, that will be the position of our x naught, that is the shifted position of the mean. So we can say the position, the shifted mean position, rather mean position, can be found out by balancing F electric and F spring. So which basically means that F electric is equal to F spring. So substituting value, F electric is our Q upon E, Q multiplied by E. F spring is our you can say new placement is x naught K, and therefore we can say that our x naught will be equal to QE divided by K. Okay, we are not taken here negative sign, we are only interested in the magnitude of x naught. Okay, so it means now the block will oscillate about its mean position. Okay. The block is going to oscillate about this mean position, new mean position, you can say. Therefore, thus the block oscillates at this new mean position. So this is our first part. So from here we can say that part A, option A is partially correct because it is now with shifted mean position, and with same mean position, so this will not be true, and also D option will not be true. Partially with shifted mean position, this and this, it means A and C will be true. Now we have to find out about the frequency. So we can say frequency of the SHM, because we already studied that the key points of SHM, we state the frequency of SHM depends only on properties of spring. Properties of spring, or we can say that is spring constant and mass which is connected to it, which is basically m. Therefore, if for the sake of you can say clarity, let us suppose that the new frequency is represented as nu, which will be equal to 1 upon 2 pi square root of k upon m, and this is nothing but equal to nu naught. So therefore we can say that the block will be oscillating with the same frequency. So we can write it that when electric field is switched on, the mean position of the SHM position of SHM, it is given as x naught, which is equal to QE divided by K, and it means it is at the new mean position. And about the frequency, we already said that the frequency of oscillation remains same. Frequency of oscillations remain same as the natural frequency. Where nu is equal to nu naught. So now the frequency is also same, so we can say the option number C is also not correct. So option number A is our correct option. Therefore option A is correct. So this completes the question. Thank you.